The grandfather paradox. The grandfather paradox is the cornerstone of time travel paradoxes, a thought experiment that challenges the very foundations of causality, the principle that dictates cause must precede effect. It's not just a playful riddle, it's a direct confrontation with our understanding of how time, history, and existence itself are structured. Imagine yourself as a time traveler, equipped with a functioning time machine and a rather unsettling goal: to prevent your own existence. You decide to achieve this by traveling back in time to a period before your grandparents met, intending to somehow prevent their initial encounter. Perhaps you plan to convince your grandfather to move to another country, or perhaps you orchestrate a series of events that ensure they never cross paths. Let's say you succeed in your mission. Your grandparents, diverted by your interventions, never meet. They live separate lives, perhaps finding other partners, but crucially they never have the child that would become your parent. Consequently, your parent is never born. And if your parent is never born, then you are never born. This is where the paradox explodes into a logical impossibility. If you were never born, then who built the time machine? Who traveled back in time? Who interfered with your grandparents' lives? The very action you took in the past, preventing your grandparents from meeting, undermines the possibility of that action ever taking place. It creates a self-negating loop, a causal contradiction that throws our understanding of time into disarray. The grandfather paradox isn't just about family history. It's a fundamental challenge to the concept of a consistent timeline. It forces us to ask, can the past be altered in a way that undoes the present? If causes can be eliminated after their effects have already occurred, what does that mean for the stability of reality itself? The paradox highlights the potential for causality violation inherent in backward time travel, leading to discussions about whether such time travel is even fundamentally possible, or if the universe has built-in safeguards to prevent such logical impossibilities. The matricide-patricide paradox. While the grandfather paradox deals with altering your lineage through a generation removed, the matricide-patricide paradox brings the conflict into a much sharper, more personal, and arguably more disturbing focus. It's a direct and brutal variation of the grandfather paradox, concentrating on the immediate act of eliminating one's own parent before one's birth. Imagine, fueled by some powerful motive, perhaps a desire to prevent a future tragedy you believe your parent will cause, you construct a time machine. Your target isn't a distant relative, but your own mother or father. You travel back to a time when your mother is young, perhaps just starting her adult life, long before she even considers having children. You find her, and through some deliberate action, you prevent her from ever having the chance to give birth to you. You eliminate her, effectively ending her life before your own conception. Now, the logical consequences are even more immediate and stark than in the grandfather paradox. If your mother is dead before you are born, then you are never born. The chain of lineage is broken at the most crucial link, the direct connection to your own existence. But just as with the grandfather paradox, this creates an inescapable contradiction. If you were never born, how could you have traveled back in time to eliminate your mother? The act of matricide or patricide becomes an act of self-annihilation, a paradox of self-undoing existence. It's a more visceral and immediate illustration of the causal problems inherent in time travel to the past. It's like trying to erase your own foundation while simultaneously standing upon it. The paradox highlights the fundamental interconnectedness of existence and lineage. To sever the direct link to your own creation is to unravel your very being, demonstrating the raw power of causality violations in the context of time travel. The Bilka paradox. The Bilka paradox shifts the focus from altering physical events to the more abstract realm of information and its origins within a time loop. It's a puzzle that questions how new knowledge can seemingly arise from nowhere, appearing to be built into existence through the peculiar mechanics of time travel. Imagine a young scientist, brimming with potential, but struggling with a complex scientific problem. Let's say she's working on a revolutionary theory of energy, but she's stuck, facing equations that just don't seem to add up. Then one day a mysterious package arrives. Inside, with no return address or explanation, is a detailed manuscript outlining the very theory she's been struggling with, complete with solutions to all the problems she's encountered. The manuscript is brilliant, containing insights that are decades ahead of current scientific understanding. Overwhelmed and realizing the potential impact, the scientist publishes the theory under her own name. It becomes a sensation, revolutionizing the field and making her famous. Years later, now a renowned figure in her field, she develops time travel technology, perhaps inspired by the very theory she discovered. Driven by a nagging curiosity about the manuscript's origin, she travels to the future, hoping to find the true author of the groundbreaking work. In the future, she investigates the history of her field. To her astonishment, she finds that she is credited as the sole originator of the theory, There's no mention of any prior source, no hint of the theory existing before she published it. This is where the Bilka paradox emerges. Where did the information in the manuscript actually come from? It traveled from the future to the past, allowing her to discover it, but its existence in the future depends on her having introduced it in the past. It's a closed loop of information, seemingly created from nothing but the time travel itself. The paradox challenges our understanding of intellectual property, originality, and the very nature of how knowledge is generated and disseminated, suggesting the unsettling possibility of information existing without a clear point of origin. The bootstrap paradox. The bootstrap paradox expands upon the Bilka paradox, broadening its scope to encompass not just information, but any object or piece of information that seems to exist within a closed temporal loop, without a discernible origin outside of that loop. It's about things that appear to bootstrap themselves into existence, pulling themselves up by their own temporal bootstraps. Imagine a time traveler who, on a journey to the past, carries with them a well-worn copy of Shakespeare's complete works. Let's say this time traveler, for some reason, leaves the book behind in the Elizabethan era. A young, aspiring playwright named William Shakespeare stumbles upon this book. Intrigued, he reads the plays, finds them brilliant, and believing them to be his own inspiration, or perhaps making a conscious decision to plagiarize, he copies them down, claiming them as his own original works. The plays become famous, Shakespeare is hailed as a literary genius, and his works are preserved for centuries. Centuries later, a time traveler, inspired by Shakespeare's plays, travels back to the Elizabethan era, carrying with them a complete collection of those very plays, and the cycle repeats. The question at the heart of the bootstrap paradox is, where did Shakespeare's plays originally come from? They appear to have no origin outside of this time loop. The future time traveler brought them to the past, but their existence in the future depends on Shakespeare having written them in the past, inspired by the book from the future. It's a self-sustaining causal loop, a circle of creation with no beginning or end. The paradox challenges our fundamental understanding of origins and causality. Does everything need an external cause, or can something, through the peculiar mechanics of time travel, be its own cause, existing solely within a closed temporal loop? The bootstrap paradox makes us question the very nature of creation and existence in a universe where time can fold back on itself. The predestination paradox, self-fulfilling prophecy in time. The predestination paradox shifts the focus from altering the past through direct action to the ironic possibility that attempts to prevent a future event can, through time travel, become the very cause of that event. It's a self-fulfilling prophecy written into the fabric of time, where the traveler's actions intended to avert destiny, ironically fulfill it. Imagine a historian who learns of a devastating future event, perhaps a catastrophic asteroid impact. Armed with this knowledge and a time machine, the historian travels back in time, determined to prevent the disaster. Let's say the historian believes the asteroid impact was triggered by a specific, flawed experiment conducted by a particular scientist in the past. The historian's plan is to go back and sabotage this experiment, believing that by doing so, they will prevent the chain of events that leads to the asteroid impact. The historian arrives in the past, locates the scientist, and attempts to interfere with the experiment. However, in the process of trying to sabotage the experiment, the historian inadvertently causes a crucial component to malfunction in a different way than originally occurred. This new malfunction, triggered by the historian's intervention, sets off an unexpected chain reaction, which, ironically, is precisely what causes the asteroid to be dislodged from its orbit and set on a collision course with Earth. The historian, horrified, realizes that their attempt to prevent the asteroid impact was, in fact, the cause of the very disaster they sought to avert. This is the core of the predestination paradox. The time traveler's journey to the past, motivated by a desire to change history, becomes an integral part of the predetermined timeline, fulfilling the very event they were trying to prevent. It's a paradox of fate, where the attempt to escape destiny only serves to ensure its occurrence. The predestination paradox raises profound questions about free will and determinism. If the timeline is, in some sense, fixed, does it mean that our actions, even our attempts to change the past, are already predetermined and ultimately serve only to fulfill a pre-written history? The Polchinski paradox, self-intersecting trajectories. The Polchinski paradox, named after physicist Joseph Polchinski, moves away from grand historical events and personal lineages to focus on the potential for logical inconsistencies in time travel involving physical objects and their trajectories. It's a thought experiment that uses a surprisingly simple setup, a billiard ball and a wormhole, to illustrate the profound challenges of maintaining causal consistency in a universe that might allow for time travel. Imagine a physicist has created a wormhole, a theoretical tunnel through spacetime that connects two different points in time. One end of the wormhole is on a billiard table in the present, The other end is also on the same billiard table, but it leads to a point in time, a few seconds in the past. The physicist sets up a scenario where a billiard ball is rolled towards the present-day entrance of the wormhole. The trajectory is carefully calculated so that if the ball enters the wormhole, it will emerge from the past-time exit before it entered, and on a collision course with its past self. In other words, the future billiard ball is destined to collide with the very same billiard ball that is about to enter the wormhole, potentially knocking it off course and preventing it from entering the wormhole in the first place. This is the heart of the Polchinski paradox. If the ball does enter the wormhole, it will emerge in the past and prevent itself from entering, but if it doesn't enter the wormhole, there's no future self to prevent its entry. It's a self-contradictory loop of cause and effect, a billiard ball caught in a temporal catch-22. The paradox highlights the fundamental problem of maintaining self-consistency in a universe that might allow for objects to interact with their own past selves. It raises the question of whether the laws of physics would somehow conspire to prevent such paradoxical scenarios from ever occurring, perhaps by subtly altering trajectories or even preventing the formation of wormholes that could lead to such inconsistencies. The twin paradox, relativity and time dilation. The twin paradox, while frequently discussed in the context of time travel, isn't a paradox of backward time travel creating logical contradictions. It's a consequence of Einstein's theory of special relativity and the phenomenon of time dilation, which describes how time can pass differently for observers in relative motion. It's often misinterpreted as a time travel paradox because it deals with the seemingly paradoxical idea of differential agging. Imagine identical twins, one an astronaut Alice and the other a homebody Bob. Alice embarks on a high-speed space journey, traveling at a significant fraction of the speed of light to a distant star and back. Bob remains on Earth. According to special relativity, time dilation occurs when objects move at high speeds relative to each other. For Alice, traveling at near-light speed, time will pass slower relative to Bob, who is stationary on Earth. This isn't an illusion or a malfunction of clocks, it's a fundamental aspect of how spacetime behaves, as described by Einstein's theory. When Alice returns to Earth, a significant amount of time has passed for Bob, perhaps decades. However, for Alice, due to time dilation, much less time has passed, perhaps only a few years. The paradox arises because it seems counterintuitive. Why should one twin age differently just because they took a space trip? Shouldn't the situation be symmetrical, with each twin observing the other's time slowing down? The resolution lies in the asymmetry of the situation. Alice, the astronaut, undergoes acceleration and deceleration during her journey to reach near-light speed, to turn around and to return to Earth. Bob on Earth remains in a relatively inertial, non-accelerating frame of reference. This difference in acceleration is crucial. Special relativity's time dilation effects apply specifically to comparisons between different inertial frames, and Alice changes frames multiple times, while Bob stays in essentially the same frame. The twin paradox isn't a logical contradiction. It's a consequence of the way spacetime behaves, demonstrating that time is not absolute but relative to the observer's motion. It is related to time travel, in the sense that Alice effectively travels into Bob's future by agging slower, but it does not involve backward time travel or the creation of logical paradoxes. The Novikov self-consistency principle, a proposed solution. The Novikov self-consistency principle, proposed by physicist Igor Novikov, isn't a paradox itself, but rather a proposed solution to the logical problems raised by time travel paradoxes, particularly those involving changing the past. It suggests that if time travel to the past were possible, the universe would operate in a way that prevents paradoxes from ever actually occurring. Think of it as a built-in, cosmic paradox prevention system. The principle asserts that any actions taken by a time traveler in the past will always be consistent with the already established timeline. Imagine you travel back in time with the intention of creating a grandfather paradox. According to the Novikov self-consistency principle, even if you try to prevent your grandparents from meeting, something will always intervene to ensure that they do meet, and that you are born. Perhaps your attempts are clumsy and ineffective, or perhaps unforeseen events conspire to bring your grandparents together despite your interference. No matter what you do, the timeline will self-correct to maintain consistency. The principle doesn't explain how this consistency is enforced, it simply postulates that it must be. This implies a limitation on free will in the past. Your actions are constrained by the requirement of maintaining a consistent timeline. You can only do things that were already part of the past that led to your present. The timeline is, in a sense, self-healing, deflecting any attempts to create paradoxical situations. While not a paradox itself, the Novikov principle is deeply related to paradoxes, as it's a direct response to their potential for disrupting causality. It's an attempt to make time travel logically viable by essentially banning paradoxes. It raises philosophical questions about determinism and the extent to which we truly have agency, even in the present, if the past and future are locked into a self-consistent loop. The chronology protection conjecture, Hawking's idea. The chronology protection conjecture, proposed by Stephen Hawking, offers a different approach to resolving time travel paradoxes than the Novikov self-consistency principle. Instead of suggesting the universe allows time travel but enforces consistency, Hawking's conjecture posits that the fundamental laws of physics might prevent time travel to the past from ever becoming possible in the first place. It's a cosmic no-entry sign for backward time travel, designed to avoid the headaches of paradoxes altogether. Hawking's concern stemmed from the theoretical possibility of closed time-like curves, CTCs, paths in spacetime that loop back on themselves, potentially allowing for time travel. He argued that if time travel to the past were readily achievable, the resulting paradoxes could unravel the very fabric of causality and undermine the foundations of physics. The chronology protection conjecture essentially states that the laws of physics will conspire to prevent the formation of CTCs. It doesn't specify the exact mechanism, but suggests it might involve quantum effects. Near the conditions that would create a CTC, like a wormhole, quantum fluctuations in the vacuum of space might become amplified to such enormous levels that they effectively destroy the wormhole or prevent the spacetime curvature necessary for time travel. It's as if the universe actively sabotages any attempt to build a time machine capable of traveling to the past. This conjecture is a direct response to the potential for paradoxes. By preventing the formation of CTCs, it eliminates the possibility of backward time travel and therefore eliminates the risk of grandfather paradoxes and other logical inconsistencies. If the chronology protection conjecture holds true, time travel to the past is simply impossible, causality is preserved, and there's no need for mechanisms like the Novikov principle to enforce consistency within a time travel-capable universe. It's important to remember that it's a conjecture, a plausible idea but not a proven theory. However, it highlights a significant tension in physics: the theoretical possibility of time travel arising from general relativity versus the deep unease and logical problems these possibilities create. The many worlds interpretation and time travel paradoxes, branching timelines. The many worlds interpretation, MWI of quantum mechanics offers a radical, and still debated, solution to time travel paradoxes, not by enforcing consistency within a single timeline, but by proposing the existence of multiple branching timelines. MWI was originally developed to address the measurement problem in quantum mechanics, but it has interesting implications for time travel. In standard quantum mechanics, a system in a superposition, existing in multiple states at once, collapses into a single definite state upon measurement. MWI rejects this collapse. Instead, it proposes that every quantum measurement, or any event with multiple possible outcomes, causes the universe to split into multiple parallel universes. Each universe represents one of the possible outcomes. For example, in Schrödinger's cat thought experiment, instead of the cat being either alive or dead, MWI suggests the universe splits into two, one where the cat is alive and another where it is dead. Both realities are equally real, but separate. Applying this to time travel, consider the grandfather paradox. If you travel back in time and prevent your grandparents from meeting, MWI suggests you don't create a logical contradiction within a single timeline. Instead, your action causes the timeline to branch. In one branch, you succeed in preventing your grandparents from meeting, and you, the time traveler from the original timeline, effectively cease to exist in that branch. But in another branch, the original timeline, you fail to prevent their meeting, and your lineage continues as before. You've essentially created a new parallel universe where you don't exist, but you still exist in the original timeline. MWI resolves paradoxes by distributing the outcomes across multiple realities, avoiding logical contradictions within any single timeline. However, it introduces its own set of paradox-like questions. Which timeline is real? What are the implications for personal identity if you create countless branching selves? It's a solution that trades logical paradoxes for a potentially infinite proliferation of realities, raising profound questions about the nature of existence itself. The Fermi paradox of time travel. Where are the time travelers? The Fermi paradox of time travel, mirroring the famous Fermi paradox concerning extraterrestrial life, shifts the focus from logical contradictions to a puzzling lack of evidence. It asks, if time travel to the past is possible, even if only in the distant future, and if it becomes relatively widespread, why haven't we been inundated with time travelers from the future? It's not a paradox of logical inconsistency, but a paradox of expectation versus observation. The expectation, based on the potential for future time travel, clashes with the observed absence of obvious time travelers in our midst. Paradox rests on a few key assumptions: that time travel to the past is not fundamentally impossible, that it might become commonplace for future civilizations, and that time travelers would be, at least to some extent, detectable. Given the vastness of time and the potential future, it seems statistically unlikely that we would be living in a period completely devoid of time travelers, if such travel were readily achievable. Yet, we see no clear evidence of visitors from the future. History seems to unfold in a generally linear and consistent way, without obvious signs of temporal interference. Possible explanations for this silence range from the straightforward time travel is simply impossible to the more speculative. Perhaps time travel is incredibly difficult or dangerous, even for advanced civilizations. Perhaps time travelers are masters of disguise and non-interference, meticulously avoiding detection. Perhaps our current era is simply uninteresting to future historians, or perhaps there are strict temporal quarantine rules in place, preventing overt visits to the past. The many worlds interpretation also offers a potential explanation. Time travelers might be branching off into alternate pasts, not altering their own original timeline, and thus remaining invisible to us. The Fermi paradox of time travel is a reminder that the absence of evidence is not necessarily evidence of absence, but it does force us to confront the implications of the potential for future time travel and the puzzling lack of its observable effects in our present. The killing baby Hitler paradox, ethical and historical ramifications. The killing baby Hitler paradox isn't a paradox of logical contradiction, but a deeply unsettling ethical and philosophical dilemma, often presented as a thought experiment about the potential consequences of time travel. It poses the stark question: if you could travel back in time, would it be morally justifiable to kill Adolf Hitler as an innocent baby, thereby preventing the Holocaust and World War II? This scenario isn't about creating a logical impossibility. It's about grappling with conflicting moral principles and the potential for unintended consequences. The argument for killing baby Hitler is primarily utilitarian, preventing immense suffering. By eliminating one life, an innocent one, at that point in time, you could potentially save millions and avert unimaginable horrors. The scale of the Holocaust makes this a seemingly overwhelming moral imperative. However, the arguments against are equally compelling. Killing an innocent, regardless of their potential future actions, violates fundamental moral principles. It raises the specter of preemptive justice, judging someone for crimes they might commit, not crimes they have committed. Furthermore, it opens a Pandora's box of unintended consequences. History is complex, and even seemingly small changes can have vast, unpredictable ripple effects, the butterfly effect. Eliminating Hitler might prevent the Holocaust, but it could also lead to other, unforeseen and potentially equally terrible outcomes. Perhaps a different, even worse dictator would rise to power. Perhaps World War II would still happen, but in a different and more devastating form. The killing baby Hitler paradox forces us to confront the potential for moral compromise, the slippery slope of preemptive action, and the profound uncertainty of altering historical events, even with the best of intentions. It highlights the immense ethical burden that the power to change the past, if it existed, would place upon us. The Oracle paradox, knowing the future and changing it. The Oracle paradox explores the intricate relationship between future knowledge, free will, and the consistency of time itself. It asks, if you could reliably know the future, could you then use that knowledge to change the future, thereby making the initial knowledge invalid? It's a puzzle centered on the concept of self-defeating prophecies. Imagine you have access to an infallible oracle, a source of perfect future knowledge, perhaps a time-viewing device. You ask the oracle, will I win the lottery next week? The oracle reveals, yes, you will win, and here are the winning numbers. Now armed with this future knowledge, you have a choice. You could try to test the oracle by deliberately not buying a lottery ticket, attempting to prove it wrong. If you don't buy a ticket, you won't win, seemingly contradicting the oracle's prediction. But if the oracle was truly infallible, its prediction should have been accurate. This is where the paradox arises. The very act of knowing the future and attempting to change it seems to invalidate the future knowledge itself. If the oracle's prediction is contingent upon your actions, and your actions are influenced by the prediction, a self-referential loop is created. Alternatively, you could trust the oracle and buy a ticket with the winning numbers, fulfilling the prediction. This seems consistent, but the paradox lies in the first scenario. The oracle paradox isn't about physically altering the past, but about the logical consistency of knowing the future and having the freedom to act upon that knowledge. Does true free will exist if the future is knowable? Or does the paradox suggest that our choices, even those based on future knowledge, are somehow already factored into the predetermined future that the oracle reveals? It's a thought experiment that probes the very nature of prophecy, determinism, and the limits of knowledge within the flow of time. The inventor's paradox, origin of invention through time travel. The inventor's paradox, closely related to the Bootstrap and Bilka paradoxes, focuses on the perplexing question of where inventions originate when time travel creates a closed loop of information. It asks, if an invention is seemingly passed from the future to the past, and then becomes invented in the past based on that future knowledge, where did the idea for the invention initially come from? Imagine a struggling inventor working on a revolutionary new technology. They're close but missing a crucial piece of the puzzle. Then, mysteriously, they receive detailed blueprints and technical specifications for the very technology they're trying to create. These plans are far more advanced than anything currently known. The inventor, using these future plans, successfully builds the technology, becoming famous and hailed as the original inventor. Years later, driven by curiosity about the blueprint's origin, the inventor develops time travel and journeys to the future, hoping to find the true source of the invention. In the future, they discover that they themselves in the past are credited as the inventor. There's no record of any prior source. The invention seems to have originated with them, but only because they received the plans from the future, which in turn were based on their own invention in the past. It's a circular loop of creation with no discernible starting point. The invention appears to be self-originating, bootstrapped into existence through time travel. The paradox challenges our understanding of originality, intellectual property, and the causal chain of innovation. Normally, inventions build upon prior knowledge and discoveries in a linear progression. The inventor's paradox disrupts this linearity, suggesting a scenario where an invention can exist without a true, external originator, its existence solely contained within a temporal loop. It raises questions about what it truly means to invent, something if the core idea itself is temporally displaced and lacks a clear point of origin. The lottery paradox, future knowledge for personal gain. The lottery paradox explores the implications of using time travel for personal financial enrichment, specifically by obtaining future lottery numbers and using them to win in the past. It's not a paradox of logical contradiction in the same way as the grandfather paradox, but rather a paradox of consistency, fairness, and the nature of chance. Imagine someone, driven by a desire for wealth, manages to travel to the future, perhaps just a week ahead. They carefully note the winning lottery numbers from a future drawing and then return to their own time, just before that same drawing takes place. Armed with this future knowledge, they buy a lottery ticket with the winning numbers and, unsurprisingly, win the jackpot. On the surface, it seems like a straightforward success. They used time travel to gain an unfair advantage and profited from it. But the paradox emerges when we consider the implications of this act. Lotteries are designed to be games of chance, where the outcome is unpredictable and random. The time traveler has effectively removed the element of chance, guaranteeing their win. This undermines the very foundation of the lottery system. The paradox raises questions about causality and determinism. Did the time traveler cause themselves to win, or was winning the lottery already a predetermined event that they simply became aware of through time travel? It also touches upon the concept of information flow. In a normal lottery, the winning numbers are generated randomly in the present. In this scenario, the knowledge of those numbers appears to originate in the future, creating a subtle form of information bootstrap. Furthermore, it raises ethical questions about fairness and the integrity of systems built on chance and uncertainty. If time travel for personal gain became widespread, what would be the economic and societal consequences? The lottery paradox, while not a hard logical paradox, highlights the unsettling implications of using future knowledge to manipulate systems designed to be governed by randomness. The paradox of identity and self-meeting, multiple selves. The paradox of identity and self-meeting shifts the focus from altering timelines or gaining advantages to the deeply personal and philosophical implications of encountering your past self through time travel. It asks, what happens when you meet yourself from a different point in time? What are the implications for your identity, your sense of self, and your understanding of who you are? Imagine you build a time machine and, driven by curiosity or a desire for self-reflection, you travel back to a point in your own past. You choose a time, perhaps 10 years earlier, and arrive to observe your younger self. Simply seeing your past self can be a disorienting experience. There you are, younger, perhaps with different aspirations and anxieties, yet undeniably you. But the paradox intensifies if interaction occurs. What if your past self notices you? What if you speak to each other? This encounter immediately raises questions about identity. Is your past self still you, even though you've lived through years of experiences they haven't yet had? What are the psychological effects of confronting a past version of yourself, someone who shares your history, but is also, in some ways, a stranger? If you give your past self advice, warning them about mistakes you made or guiding them towards better choices, you are directly altering your own past. Does this create a personal version of the grandfather paradox? If your past self's life changes significantly based on your intervention, does it change the you that traveled back in time? The paradox isn't primarily about logical contradictions in the timeline, it's about the philosophical complexities of personal identity across time. It forces us to confront what makes us us. Is it our memories, our physical continuity, our consciousness, or something else entirely? Meeting your past self highlights both the continuity and the discontinuity of personal identity, raising profound questions about the nature of self and the subjective experience of time. The fixed past paradox, determinism and lack of agency. The fixed past paradox, also known as the immutable timeline paradox, isn't about creating logical contradictions by changing the past. Instead, it explores the potential limitations of time travel if the past is fundamentally unchangeable. It suggests that if the past is fixed and immutable, then any time travel to the past is restricted to observing or participating in events that were always destined to happen. You can't alter history, you can only be a part of its preordained unfolding. Imagine a universe where the timeline is like a completed film reel. Every event from beginning to end is already set, unchangeable. If you were to build a time machine in such a universe and travel to the past, you could witness historical events firsthand, but any attempt to change those events would be futile. Let's say you travel back to witness a famous historical battle. You might observe the battle unfold, perhaps even get close to the action, but if you tried to intervene, to save a particular soldier, to alter the outcome of the battle, you would inevitably fail. Why? Because the outcome of the battle, as it always happened, is already fixed in the immutable timeline. Your actions, even your very presence in the past, must already be accounted for in that fixed history. Your attempts to change things might be thwarted by unforeseen circumstances, or perhaps your actions, even if they seem impactful, were always part of how events unfolded. You might believe you are changing history, but in reality you are simply fulfilling it. The fixed past paradox implies a strongly deterministic universe, where free will, at least in the context of influencing the past, is severely limited, if not illusory. Time travelers in a fixed past are essentially observers, or perhaps minor participants in a pre-written play, unable to alter the script in any significant way. It raises the question of the purpose of time travel to the past, if meaningful change is impossible, reducing it to a form of historical tourism or passive observation. The mutable past paradox, timeline instability. The mutable past paradox presents the opposite scenario to the fixed past. It assumes that the past can be changed, and that even seemingly small alterations can have significant, cascading consequences. It's not a paradox of logical contradiction, but a paradox of potential instability. If the past is like wet clay, easily reshaped, what prevents runaway changes and a timeline that spirals into chaos? Imagine a universe where time travel is possible, and interventions in the past have real and lasting effects. Unlike a self-correcting universe, as in the Novikov principle, or a fixed timeline, changes in this scenario stick and propagate. Even a seemingly insignificant action in the past, like moving a small object or saying a few words to the wrong person, could trigger a chain of events that leads to a drastically different future, the butterfly effect in its most extreme form. Let's say you travel back in time and accidentally step on a butterfly. In a mutable past universe, this seemingly trivial act could alter weather patterns, affect plant growth, influence animal migration, and over centuries lead to a completely unrecognizable present, vastly different from the one you left behind. If multiple time travelers are making changes, even with good intentions, the cumulative effect could be catastrophic, leading to a timeline that is constantly shifting and unstable. The paradox lies in the potential for runaway chaos. If the past is so easily altered, what prevents the timeline from becoming a jumbled mess of conflicting changes and unpredictable outcomes? Where are the stabilizing forces? The mutable past paradox suggests a timeline that is incredibly fragile, vulnerable to even the slightest temporal nudge. It raises questions about the coherence of history, the predictability of the future, and the very possibility of a stable reality if the past is constantly being rewritten. It's a scenario where even well-intentioned interventions could have devastating and unforeseen consequences, leading to a present that is perpetually in flux and potentially unrecognizable. The absence of time tourists paradox, practicality and detectability. The absence of time tourists paradox, much like the Fermi paradox concerning extraterrestrial life, deals with the puzzling lack of observable evidence for time travelers in our world, assuming time travel might be theoretically possible in the future. It asks, if time travel to the past becomes feasible, and if it becomes relatively common, why don't we see obvious signs of time travelers, time tourists, visiting our present from the future? It's not a paradox of logical contradiction, but a paradox of observation, or rather, the lack thereof. This paradox doesn't hinge on the mechanics of time travel, creating logical impossibilities. Instead, it highlights a potential disconnect between the theoretical possibility of time travel and the practical reality of our current experience. If future civilizations develop time travel technology, and if there are no fundamental laws preventing its widespread use, one might expect a significant influx of visitors from the future, curious to witness historical events or experience different eras. Yet we see no such influx. Our world, as far as we can tell, is devoid of obvious time travelers. This absence could be explained by several factors, even if time travel is theoretically possible. Perhaps time travel is incredibly difficult, energy-intensive, or dangerous, even for advanced civilizations, making it a rare and restricted activity. Perhaps time travelers are exceptionally skilled at remaining undetected, using advanced camouflage or adhering to strict rules of non-interference. It's possible that our current era is simply uninteresting to future historians, or that there are strict temporal quarantine protocols in place, preventing overt visits to the past. The paradox underscores that the absence of evidence is not necessarily evidence of absence. However, it does encourage us to consider the practical, ethical, and logistical constraints that might limit the visibility of time travel, even if it becomes scientifically feasible in the future. It suggests that time travel, if it exists, might be a far more subtle and less pervasive phenomenon than often depicted in science fiction. The philosophical zombie time traveler, paradox, consciousness and time travel. The philosophical zombie time traveler, paradox delves into the deep philosophical questions surrounding consciousness and personal identity in the context of time travel, specifically replication-based time travel. It's not a paradox of logical contradiction within the timeline, but rather a paradox concerning the very nature of subjective experience. It asks, if you could perfectly replicate a person and send that copy back in time, is the past you still you in a meaningful, conscious sense, or just a philosophical zombie, a perfect imitation lacking genuine inner experience? To understand this paradox, consider the concept of a philosophical zombie, p-zombie. In philosophy of mind, a p-zombie is a hypothetical being that is physically identical to a conscious human, capable of behaving in exactly the same way, but lacking any subjective experience or qualia. There's nothing it is like to be a p-zombie, it's a perfect automaton. Now, imagine a time travel technology that works by perfectly replicating a person, down to the quantum level, and sending that replica to the past. If you were to use this technology, a perfect copy of you would appear in the past, possessing all your memories, personality traits, and physical characteristics. The paradox arises when we consider the consciousness of this past copy. Is the past you genuinely conscious, experiencing the world in the same way as the original you? Or is the past copy merely a p-zombie, a perfect imitation behaving as if it were conscious, but lacking any inner subjective awareness? The original you remains in the present with your continuous stream of consciousness. The past you is a new physical entity, even if created from a perfect copy. Does consciousness transfer along with the physical replication, or does it remain solely with the original? The paradox highlights the fundamental mystery of consciousness itself. We don't fully understand what gives rise to subjective experience, and time travel, particularly replication-based time travel, throws this mystery into sharp relief, forcing us to confront the limits of our understanding of what it means to be a conscious, self-aware being.